Hi everyone, my name is Tim Guy. Please pardon my voice, I'm a little sick right now. Here's my Module 1 screencast. Just to get started, a little bit about me. I'm currently married. I have one child, Claire, who is 1.5 years old, and I'm expecting one more on the way, so I'm super excited. That's going to be happening in March. Some fun things that I like to do, some of my hobbies, I'm really a big fan of board games, video games, big fan of sports. The Eagles finally won the Super Bowl. It's so awesome. And my favorite candy bar is Baby Ruth. Who doesn't love Baby Ruths? Usually people don't list that one, but I think it's great. I currently teach at Spring Grove Middle School. I'm an 8th grade math teacher. I teach pre-algebra, Algebra 1, and Algebra 2. So I kind of have a full gamut of ability levels and just different courses that I teach. So my school is a one-to-one school, meaning all my students currently have iPads that they use. So STEM was really an interest to me for my major because I wanted to figure out how to effectively use as one-to-one things in my classroom. I also really am interested in how to develop thinking in my students and make them better mathematical thinkers, and how can I get them to kind of reach that sort of spot I want them to get to. And additionally, I want to know how to get more and more students engaged and interested in mathematics, because I really don't like the whole, oh, math is boring, blah, blah, blah. I want to be able to move past that with my students. So how do students learn science? The big thing that stuck out to me that I wanted to point out were the 3 principles of learning science at the beginning of the one chapter that we had to read. The big things that you really need to make sure you address whenever you're doing student learning is to address their preconceptions and misconceptions. And in science, you can do that in a lot of different ways. You can do it through experiments, through inductive learning. There's a lot of different methods you can do for that. The next thing you need to do is develop competence in your students, and that means not only giving them knowledge and facts, but a way to organize those and connect those. They kind of went through and misproved the fact that, just knowing facts isn't good. You also have to be able to understand how to use it, and that's true, but being able to connect all that together is what makes you even better at doing something. And then last but not least, being metacognitively thinking about what's going on. Basically being able to go back and reflect on what you did and what could you do better. That's really the basis of scientific thought in general, and really to learn anything, you have to be able to evaluate your processes. So some barriers to learning science, one of them already mentioned, is one of the things we have to address, this preconceptions and misconceptions. Students come in with things that they think they know all the time that have to do with whatever you're teaching. And that even happens in math. Students come in with things they think they know. So we have to make sure that we approach those in a way that makes students kind of go with what we want them to know. Also, another barrier to students learning science is how the teacher decides to approach their classroom. These 4 things were listed as sort of what you kind of want to overlap and make sure you include all these things that have a really student-centered classroom. So there's learning-centered, student-centered, knowledge-centered, assessment-centered, community-centered. And once you have all those things kind of involved, you really have a true student-centered classroom where students can learn and kind of break down some of those barriers, those cultural barriers that might show up. So in my classroom, I think that I do a really good job of having some inquiry present. I do a lot of do-nows and warm-ups that are more getting kids thinking about a problem or getting them set up to like, oh, why would we do this? Or what's wrong with this? To really kind of get them motivated to do what we're going to do in class. And then I also like to do a lot of guess and check and trial and error, and then kind of show them, oh, well, that way might have led you here, but here's another way to solve this problem. And then I also focus a lot with my students on growth mindset and really on thinking about how they can improve their processes and what they're doing. So here's my kind of breakdown for what I think STEM is. I think that STEM really is a way of learning, getting kids to think about how to think. And once you kind of give them those tools of how to learn and how to think about problems and problem solving, they can apply it to all different courses, not just the traditional STEM courses, but also some of their social studies and arts courses. Thank you very much for watching my Module 1 presentation.